Good morning. We are still in Unit 3. We're talking about functions. Today is Lesson 2, Introduction to Functions, Basic Domain and Range. So for the warm-up for the first two questions, we're going to plot those points. So 2, 0 means right 2 and up 0, which is right here. Negative 5, 3 means left 5. So 1, 2, 3, 4, 5, and down 3. No, excuse me, that's positive. So up 3. 1, 2, 3. So there's my dot. 5, 1 means right 5. So 1, 2, 3, 4, 5, and up 1. And negative 5, 5 means left 5. 1, 2, 3, 4, 5, and up 5. 1, 2, 3, 4, 5. From what I could tell, you guys are all really comfortable with plotting points, which is terrific. Now, the next one, we want to identify the coordinates or the ordered pairs on the graph. So A looks like it goes right 4 and then down 4. So this would be 4, negative 4. Remember, you have to use those parentheses. B would be left 4 and down 3. So negative 4, negative 3. C goes left to right 0, but it goes up 4. So that's 0, 4. And letter D is left 6 and then up 5. Left 6 and then up 5. So remember that first number is left and right, and then the second number is up and down, plotting points. So relations and function. A relation is an ordered pair. Or a set of ordered pairs. Let's do it this way, a set of ordered pairs. There you go. Sorry, I changed my mind. Every relation consists of a domain and a range. The domain is the independent variable, but we often call it the input. And for us, that winds up to be the x value. The range is the dependent variable. And that's the output. For us, that's the y value. When listing domain and range, domain is list of the x values. And the range is the list of y values. There are 4 different ways that we can represent a relation. The first one is ordered pairs. The second one is a table. The third one is plotting points or graph. Let's go with a graph. And then number 4, this is called a mapping diagram. I hope you saw that before. I feel like you did, but this is the x on the input and this is the y on the output. And so it shows you how they match up. So example 1, identify the domain and range of each relation. So for the domain, we're just going to write the word domain. I'm going to use this funny bracket. And the domain is all of the x values. The x values come first. So it's 2, negative 5, 5, and negative 5. Now, some people will have you list them in order from least to greatest. So negative 5, 2, and 5. And then you want to list the range. The range are all of the y values. So 0, 3, 1, and 5. And again, sometimes when you look these up, they have you do them in order. So they could look like that. There we go. Domain and range again. So my domain on this one are your x values. Now to get them off of the graph, this has an x value of negative 2. And then over here at 1, and then at 2, and then at 3. My range are the y values. So now I'm going to look at it in the other direction. So -2, none here at -1, none at 0. Up here at 1, I've got 2 of them. Actually, I guess I should list that twice. And then up here at 3. And so I should list that -2 twice as well, because I've got 2 of those down there. Then if I adjust my red ones up here, I've got 2 -2s going up and down. Sometimes for domain and range, they'll have them list you multiple times where this shows up both. I like them both because then I can tell if it's a function or not, but they don't always have you write the repeats. So I kind of like the repeats, but that's just me. And making fudge brownies, domain is the baking powder. So that goes, that's my input, 3, 4, 5, and 6. And then my range is the output, which is 2.43, 2.99, 3.55, and 4.11. Here we go. The next one, example 2, make a mapping diagram. So we have our input, which is the X that goes in one box or one circle, and the output, which is the Y. Now, the input, remember, that's our domain. So I've got a -1, a 3, a -5, and a 3. So we usually put those in order. So here's, how did they do this one? -5, -1, 3. Now on a mapping diagram, you don't list that 3 twice. You only list it once. And then for the output, for the range, we have -2, 6, -10, and 2. So let's do -10, -2, 2, and 6. All right, so now we have to draw arrows to match them up. Let's use this color green. So -1 matches with -2. So we draw an arrow all the way across. Check. 3 matches with 6. Check. -5 matches with -10. Check. And 3 matches with the 2. So now I have to reuse this 3, and that's perfectly fine over here with the 2. Done. Good job. Now, why don't you take a second, you try to make a mapping diagram for the relation. All right, I've put in all the X's and all the Y's. Now I'm going to match them up. So 0 goes with 7. 3 goes with 3. 0 goes with 2. And 2 goes with 4. And it's okay that they crisscross the lines. That's totally fine. Good, that's our mapping diagram. A what is a relation in which every what only has what. So a function is a relation in which every input has only one output. In order for a relation to be a function, it has to be in ordered pairs and tables. No X values are allowed to repeat. On a graph, it has to pass the vertical line test. And in a mapping diagram, only one arrow from X to Y. So determine if it's a function or not. So ordered pairs, no X values repeat. So let's check. Here's 2, -1, 0, and 4. I don't care about the Y values, but did any of those X values repeat? Nope. So yes, this is a function. For the next one on a graph, passes a vertical line test. A vertical line goes up and down. It's only allowed to touch the vertical line once in order to be a function, no matter where I draw a vertical line. So my vertical line that's green touches that curve, which is red, more than once. So this one is no, not a function. And then on a mapping diagram, only one arrow from each X. So this only has one arrow, one arrow, one arrow. Oops, this one's got 2. So this one is a no. All right, determine if each of the values is a function or not. So again, let's check that table. -2, -1, 0, and 3. This one's a yes. Letter B is a graph, so we have a vertical line test. So each time you draw a vertical line, it's only allowed to touch once. So this passes our vertical line test. This is a yes function. And then letter C, each x value can only have one arrow out, and all of these do. So this one is also a yes. So in this case, all of these are a function. Example 3, match each graph with its related table. So you want to match the values. So this one starts at 150, which this is 160, this is 180, this is 150. So let's keep checking. 150, 2, 100, 3, 150, and 4, 200. All right, so A is number 3. Letter B starts out at 180, which this one starts out at 180, 2, 125, 3, 150, I agree, and 4, 140. So this one is number 2. And letter C, finally. 160, yeah, that looks like 160. 2, 120, I agree. 3, 180, and 4, 240. Good, so this is number 1. Match him up. All right, there we go, folks. That's what I have for domain and range today. So what I'm going to have you do is list out domain and range like this. And then sometimes we have to make a mapping diagram. So good job, and let me know if you have questions.